okay, to start, that numbers 1 through 5, okay, and yeah, 1 through 5 have the inverse on the outside of the parentheses, okay, and that 6 through 9 have the inverse on the inside of the parentheses. Okay? Question already?
Yes. Is it 6 through 9? Is it just like a typo that there's no pi in there?
No.
Or is that we're gonna get to that later?
Nope, there's not a typo.
Okay.
Okay? Because 1 through 5, okay, you're going to find the cosine of the angle value first. Okay? And then you're going to do the inverse of that angle to come up with what its x or y value is, depending on what it's asking. Okay? So it's not a typo.
Okay.
Yes?
Is the only difference between like sine and arc sine is that they have different ranges or different domains?
Well, that's what we're going to start with right now.
Okay.
Okay? Got it? All right, so here we go. First thing that we need to understand, okay, is that whenever we are doing like a sine inverse or a cosine inverse, remember that the x value has to be greater than or equal to -1 and less than or equal to 1. Okay, and that's when we're doing the inverse. Okay, as in you cannot do the sine inverse of pi because that's 3.14, which is greater than 1. Number 10 from last night's homework, it said find the cosine inverse of 2 pi, which is 6.28, which is greater than 1. Are we good on that? Everybody clear?
Wait,
Okay.
is it supposed to be a negative one or a 1?
Sorry, that should be a -1.
Okay.
Thank you. Yes.
Then it can
Okay.
only be-
All right. So we have to be between -1 and 1. Can I put that away? Thank you. All right. Next. Notice that there's no stipulation for tangent. And the reason is tangent can go from -infinity to infinity. And so like when you look at question number 8 with the 30, okay, we're going to be able to do that one. Like you're probably thinking, oh, well, it's not between -1 and 1. Okay? Why can we do tangents? Okay? Remember that your tangent curve, okay, does this, right? So it's going from -infinity to infinity, right? Okay? Whereas your sine and cosine curve, remember cosine starts at 1 and comes all the way down to -1. Your sine curve starts at 0, okay, goes up, and then comes back down to -1, okay? Or since we're doing from -pi/2 to pi/2, it's starting at -1 at -pi/2 and going up to 1 at pi/2, okay? So it has stipulations. It has to be between -1 and 1. Tangent doesn't, because it can go from -infinity to infinity, okay? Are we clear on that? All right, so remember that's for inverse. Okay? Now, when we are doing regular, like cosine, sine, and tan, okay? So, when we're dealing with those things, reminder that sine and tangent have to be a value between -pi/2 and pi/2. So this is for sine and for tangent. So it has to come from quadrant 1 or quadrant 4. So Lauren, that was kind of your question because you wanted 2 answers, right? But we said there's only going to be 1 answer, okay? Cosine goes from 0 to pi, okay? So those are the values that we are dealing with. Now, when we're dealing with these, we can come up with an alternate ego, okay? Because there's 2 values that will give us like a √3/2. One in the first quadrant, one in the second quadrant if it's sine. One in the first quadrant, one in the fourth quadrant if it's cosine. So on and so forth, okay? So, for example, let's say that they want us to find sine of 3 pi over 4. Well, right away, you should be saying, well, Miss Kelly, that is not between negative pi over 2 and pi over 2, right? Because that would be over here. What would be the equivalent sine value for 3 pi over 4 that is between negative pi over 2 and pi over 2? Not the 7 pi over 4, because we need a positive one, not a negative one. How about non-negative pi over 4?
Regular pi over.
Isn't it just regular pi over 4?
Yes.
Because all students we're looking for this one. So 3 pi over 4, okay, isn't that a root 2 over 2
Yep.
for sine?
Yep.
And then you guys, so like Gian and Lauren, you guys were giving me the one down here. Isn't that negative root 2 over 2? I want a positive root 2 over 2. So I am going to say that sine of 3 pi over 4 is equal to sine of pi over 4. Are you okay with that? Do you agree that sine of 3 pi over 4 is equal to sine of pi over 4?
Yeah.
Yes?
Yes.
Okay. So that's important because remember, this is not between negative pi over 2 and pi over 2, but this is between negative pi over 2 and pi over 2. So we're going to use this one. Question.
Does that work with cosine and tangent as well?
It works for cosine and tangent as well.
So, you
So
can
I
just
just,
keep subtracting pi over 2 until you get one that falls in between. Is that how that would work?
well, I chose pi over 4, which works out perfectly to be pi over 2, so it doesn't always work out that way, that you're just, because for example, okay, since you brought it up, okay, what if I had done, like in the example that we're going to see up here, sine of 2 pi over 3?
Oh, you'd have to.
Its alternate ego is going to be pi over 3, so
Okay.
you wouldn't subtract pi over 2,
Gotcha.
okay? All right? All right, so here's why what I just did here is important, okay? Numbers 1 through 5. Since you're doing the sine, cosine, tangent part first, since, you know, in terms of order of operations, we work from the inside out, the very first thing you just have to check is, for sine, is pi over 4 between pi over 2 and negative pi over 2?
Yes.
All right, guess what? Anytime you do the inverse of a sine, they just negate each other, and you get pi over 4. Love it.
Oh.
Number 2, is 3 pi over 4 between 0 and pi? All right, then these cancel each other out, and your answer is 3 pi over 4. Love it. Number 3, is negative pi over 6 between negative pi over 2 and pi over 2? Then they cancel each other out, and it's negative pi over 6. How are we doing? Okay?
Good.
So now we get to number 4. Is 2 pi over 3 between negative pi over 2 and pi over 2?
No.
No. Okay. So think about it this way. If I need to do it the long way around, all right, what is sine of 2 pi over 3? What is it? Use your unit circle. Root 3 over 2. All right, so basically this is saying find arc sine of root 3 over 2. Okay, so now, Lauren, you've been asking this. How many values have root 3 over 2 for sine? 2 pi over 3 is one of them. What's the other one?
Pi over 3.
So, basically, instead of doing arc sine of 2 pi over 3, can't I do arc sine of pi over 3 instead? And what would I get? I would get pi over 3. And the reason is because when you do sine of 2 pi over 3, you get root 3 divided by 2, okay? And one of the answers for the sine inverse of root 3 over 2 is pi over 3. And this number is between negative pi over 2 and pi over 2, whereas this one is not.
Excuse me, 4.
Yes,
What are the answers?
it's pi over 3 is your answer.
Pi over 3.
Pi over 3. Okay? Questions on that? Okay, so you have a chance to test it out another time. Number 5. Now remember, cosine has to be between what two values? 0 and pi. Is 5 pi over 4 between 0 and pi? No, it is not. Okay, so what would the alter ego be for 5 pi over 4? Okay, I heard 3 pi over 4. Do you agree with that? Okay, so therefore, this is the same question as the cosine inverse of cosine of 3 pi over 4. And now, cosine and cosine just cancel each other out, and I get 3 pi over 4. Question?
So we're looking for a value that, like, they have the same cosine value, but one that's in between the two.
Correct. And that is basically within this concept right here of quadrant 1 and quadrant 4 for sine and tangent, and quadrant 1 and quadrant 2 for cosine. Anybody else? Because now 6 through 9 are slightly different. Okay? All right. 6 through 9, now they're doing the inverse part first. So that means the very first thing you do is you check to see, at least for sine and cosine, that your value is between -1 and 1. So is 1/2 between -1 and 1? Yes. So that means our answer is just 1/2. The sine and the sine inverse just cancel each other out. Okay? So think about it this way. If you want to do it the long way around and not understand that sine and sine inverse just negate each other, what is sine inverse of 1/2? Isn't that 30 degrees? Or pi over 6? Okay. What's sine of pi over 6? 1/2. So all you're doing is you're evaluating it, and then you're unevaluating it. So that's why these can just cancel each other out. But you first have to check to see if it is in our domain and range values. Okay? So is 2/7 between -1 and 1? Okay? Then these cancel each other out, and we get 2/7. Tangent, remember we don't have to worry about it, so it's just 30. Okay? So now, is 4/3 between -1 and 1? So that means we can't even do the sine inverse of it because it's beyond the unit circle. So what would we say for this one? Undefined. And that's last night's homework. Okay? So we started with our inverse part first. Questions?
Does tan also work if it's greater than pi over 2 for like 1/5?
Okay, so for example, so you're
Let's say instead of cosine 5 pi over 4, if that's tangent 5 over 4, does that still?
then you would have to change it to something that fits within negative pi over 2 and pi over 2. So like, let's say here, okay, since we have a tangent one right here, okay, what if it had said tan inverse of tan of, let's do one that's in the third quadrant, like here, yeah, we can go 5 pi over 4, right? Does that sound okay? Okay, but 5 pi over 4 is not between negative pi over 2 and pi over 2. So give me its equivalent value. Well, that would be the one that's in the fourth quadrant, not the third quadrant, because you would reflect it over the y-axis, right? If I reflect it over the x-axis, that gets me to the second quadrant, which is still outside of the realm. So now I have to go to the one that's in the
Okay, so
third
it'd be
quadrant.
7 pi over.
7 pi over 4, but remember, 7 pi over 4 is still not between
Well, you'd
negative
have
pi
to
over
make
2
it
and pi over
negative
2.
negative pi.
So I would have to do tan inverse of tan of negative pi over 4.
Okay, but for bottom four, it doesn't matter what it is, they always cancel.
So yeah, so those,
Okay.
you are checking the idea of, since we're doing inverse, now you gotta think last night's homework, it has to be between -1 and 1 for sine and cosine. So like, see how this one, number 9 said cosine inverse of 2 pi, we said undefined,
Because it's over.
because that's 2 pi is greater than 1. Okay? Are we good? So you just have to simply understand, it depends upon what's on the inside of the parentheses, and that's how you have to start the problem. So somebody talked about, well, some of these have pi and some of them don't have pi. Well, the ones with pi, you have to check to see if it fits within our correct domain values for what we learned yesterday for inverses. Okay? All right. Second page. Notice on these, they're not just going to simply cancel out because you're doing the cosine inverse or the tangent of a cosine inverse or the sine of a cosine inverse, so on and so forth. Okay? All right. So these are going to come down to old school trigonometry, SOHCAHTOA. Okay? So you guys remember sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, all that stuff. Yes? Okay? All right. So I'm going to explain it in terms of basic concept, okay? And then when we get to number 11, we'll make it super easy, okay? All right. Basically, when I do the tan inverse of 7 over 24, I'm finding an angle measure, say theta. Okay? Using the idea of substitution, if I have tan inverse of 7 over 24, can't I substitute that for theta, because that's what tan inverse of 7 over 24 is equal to. So essentially, this is saying find sine of theta. That's essentially what it's saying. The inner part, the tan inverse of 7 over 24, is explaining the values that we have for our triangle. So if I were to draw a right triangle, and since this is positive, I'm just going to draw it in the first quadrant, okay? And it's always a right triangle, and I could put theta right here in the lower left-hand corner. Would you agree that tangent, which is opposite over adjacent, would have an opposite side of 7 and an adjacent side of 24?
Yes.
Okay? So the very first thing is sine, which is opposite over hypotenuse. I need to figure out what the hypotenuse is first. What's the length of the hypotenuse?
25.
25. Sounds like you guys remember your Pythagorean triples, 7, 24, 25. All right. So this question from the beginning is simply asking, what's sine of theta in our picture? What would we say?
7 over 25.
7 over 25 is correct. Okay? All right. So sine of tan inverse of 7 over 24. Okay? We're using the tan part to create our triangle. In shorthand version, it's saying find sine of theta. You find sine of theta by doing opposite over hypotenuse. Okay?
So this is 7 over 25.
7 over 25, like you said, yes. Okay? All right, so number 11. What I would do is simply start by just drawing a triangle. Make sure it's a right triangle. Put theta here. And since sine is 3 over 7, are you okay with the opposite being 3 and the hypotenuse being 7?
Mm-hmm.
Katie, question.
Like, so you just said it was like the answer was 7 over 25?
Yes.
The number 10. But do you have to check it on your circle or no?
Oh, no, these are not necessarily related to the unit circle,
Okay.
okay? Because if you look on your unit circle, is there any 7 over 25? No. Okay. All right, so very first thing I'm going to have to do is I'm going to have to figure out what the third side is. We're going to use Pythagorean theorem, right? So 7 squared is 49, 3 squared is 9, giving me 49 minus 9, which is 40. Square root of 40, I can simplify down to 2 root 10. Everybody good with that? All right, so what is cosine of sine of 3, sine inverse of 3/7, or essentially, what is cosine of theta in our picture? What did you say? 2 root 10 over 7, correct. She did the adjacent over the hypotenuse. Does that make sense? Question?
So, wouldn't, like, I'm just trying to like understand this, like the 3/7 is the same, so like it's sine inverse, but it's the same thing as if it was just sine, right? Like where you put it on the triangle.
Okay, so yes, so basically sine inverse of 3/7 is equal to theta. Okay, sine of theta is equal to 3/7. So you are correct that it's basically sine of your angle measure, theta in our case, is your opposite over hypotenuse. Okay? Anybody else? Okay, so then we get to number 12.
So the answer is for 11 is 2
Uh,
square 10 over 7.
2 root 10 over 7, yes. Okay, number 12. What's different about number 12?
It has tangent on the inside? Something else?
How about the fact that it's negative? Okay, so does that mean anything to us?
The triangle thing switches directions? Picture?
Okay, so where should we draw our triangle, I guess would probably be a good question. In the second quadrant. Why the second quadrant? Okay. So he's saying if we draw our triangle here, the -5 is your cosine, the 13 is your hypotenuse. Because remember, adjacent over hypotenuse. Okay, here's your theta. Okay? So I guess my question to you is, why didn't we draw it in the third quadrant? Okay, well, the hypotenuse will be positive in quadrant 3 as well. Yeah. All right, so we're only going from 0 to pi for cosine, remember the first and second quadrant, okay? So are you okay with this being 12? 5, 12, 13, Pythagorean triple? So it's positive, all right? So what is tangent of theta?
-12 over 5.
I heard -12 over 5. That it's the opposite -12 over the adjacent 5. Good? Okay? Number 13. Okay? So start by drawing a picture. All right? So where should we draw our picture? Yep. Second quadrant? Fourth quadrant? Why fourth quadrant? Because we're doing tangent, remember, is going from -pi/2 to pi/2, so it's only the first and the fourth quadrant. Okay? So we have our triangle here. Okay, so tangent is opposite -8 over adjacent 15. Anybody know what the hypotenuse is? Anybody know what their Pythagorean triples are? 17.
I was thinking so.
Okay.
Explains a lot, actually.
All right. So now, what is the cosine of theta then?
Yeah.
15 over 17. Okay? So remember, basically you're using the part inside of the parentheses to figure out your triangle, and then all you're doing is you're evaluating a new trig function. That's all you're doing. Okay? Questions?